PowerShell scripting, security. It's time to have that inevitable discussion that always comes up with computers around security. But it's really important to understand not only what PowerShell does for you from a security perspective, but what it intends to do, or what it tries to do, what it's meant to do. So we'll actually cover that first. In this nugget, we'll start by talking about the odd little way in which PowerShell makes you run scripts, its rules about file name extension associations, at least the defaults, and probably the most important and kind of misunderstood aspect of PowerShell script security, the execution policy. But before we do that, it's important that we focus on the actual goals of PowerShell security. What was the product team trying to achieve when they created these features? Well, they were, and make sure you keep track of all these little caveats, they were trying to slow down an uninformed person from unintentionally running an untrusted script. But they were never trying to create an anti-malware program. PowerShell was never intended to replace your anti-malware software. Now, as soon as you take away any one of these goals from a scenario, PowerShell's not meant to help you. It's not meant to stop someone. It's meant to slow them down. It's not meant to slow down an informed person who is intentionally trying to do something. It's not even designed to slow people from running scripts in general. It's designed to, if you want it to, slow them from running untrusted scripts, and we'll talk about exactly what that means. This is also not designed to stop someone from interactively running commands in PowerShell, provided, of course, they have permission to do whatever it is the command does. Keep in mind, PowerShell just sits on top of the .NET framework, right? You've got PowerShell, but underneath it, all of its functionality really comes from .NET. If you get a piece of malware on your computer, it doesn't need to use PowerShell to do anything. It just taps into the .NET functionality. Frankly, if you've got malware on your computer, that's your problem. The goal is to stop malware from getting on your computer. Once the malware is on your computer, you're going to have a tough time preventing it from doing stuff that the logged on user actually has permission to do. So as we talk about PowerShell security, keep all of these goals in mind. These are the things we're going to be trying to do. PowerShell is not intended to be a security barrier or a gateway or anything else. It's going to let you do whatever you have permission to do, meaning your environment permissions need to be correct, and it's going to try and slow down an uninformed user from unintentionally running an untrusted script. But PowerShell is not anti-malware. We will begin, as we so often do in Windows 7, on PowerShell version 2. Pretty much everything I'm going to show you is applicable to PowerShell version 1 and later. There's a little bit of an add-in in PowerShell version 3 that we'll talk about. So let's get started. You know what I'm going to do, just to give us something to play with, is I'm going to create a very simple script. Now you'll notice I think I have Explorer set to, actually I can never remember where anything is. I think I have Explorer set to show file name extensions. So let's try and create a new text file. No, I don't. See, it's not showing the .txt. That's kind of important. So let's just call this sample. And then I'm actually going to need to open the shell and rename that. But let's edit it real quick and just put something in here. Oh, we'll just put a simple command, write host, hello there. We really only want this in there so that we can tell if the script ran or not. We don't need to do it anything fancy. Let's get into the shell. There's that sample.txt. Rename it to sample.ps1. PS1 is PowerShell's file name extension for scripts. The 1 actually refers to the language engine in PowerShell. It's version 1 of PowerShell's scripting language. So that same version 1 scripting language has been with us since PowerShell version 1, 2, 3, and on. Now let's talk first about file name extensions. There's my file. You can see it's got a little wee PowerShell icon on it. Double click it. Opens up in Notepad. That is the default action for a PS1 file. Double clicking does not run the script. Now, the intent there was to try and slow down an uninformed user from unintentionally doing something stupid. In other words, if they've just gotten an email attachment, postcard from your mom.ps1, and they're enticed to double-click that through some social engineering language in the email, they can double-click it and they won't do any damage. It'll just open the script up in Notepad. Now, they could highlight the whole thing, copy it to the clipboard, go into the shell, paste it, hit enter, and they could run the script that way. That is not a script. That's just running a set of interactive commands. And even if this was really long, here, look, I'll add several of these. So even if the script had a lot of commands, Control A, Control C, right click, it'll run them all in sequence. A couple of things there. The commands will behave slightly differently when they're run one at a time like this than if they actually ran in the script. But this isn't the ability to copy and paste this and paste the commands into the shell. That's not a security concern because that was not the unintentional action of an uninformed person doing something accidentally. They had to take a lot of different steps to get there. So if your users can be socially engineered to doing that, doesn't that mean they could damage themselves? Well, sure it does, but couldn't they also just go into their documents folder, hit Control A, and then hit delete and delete all their documents? Well, yeah. I mean, if you've got users who can be coerced into doing things like that, well, they can be coerced into doing things. They don't need PowerShell. So the next thing is if you right-click this, you'll notice we do get a Run with PowerShell option. Now that is not the default. You have to go in and do this. You can also hit Edit. That should pop it up in PowerShell's editor, the ISE. There it is. What does Run with PowerShell do? Exactly what the name implies. Popped open a shell. It ran the script, but that was not the unintentional action of an uninformed user. So the idea is if someone's bound and determined to do something stupid, they're going to do it. You can't stop that. All of this, though, does play into a couple of other PowerShell security features. Now let's get in here into the shell. Let's say I actually wanted to run that script. What was it called? Sample.ps1. Look at this. It says sample.ps1 is not recognized as the name of a commandlet, a function, or a script file. But if I look in the directory, it's clearly right there. What the heck do you mean you don't recognize it? Well, look at the suggestion that followed this. It said I didn't find a command called sample.ps1, but there is a file in the current location. Windows PowerShell does not load commands from the current location by default. If you trust this command, instead you need to provide a path. Here's what this is designed to do. Let's say I ran dir. Am I running a command or am I running a script called dir.ps1? Now, to run a script in PowerShell, you always have to provide a path. When I use tab completion, it fills in the path for me. / just means the current path. I could also have said an absolute path. I could have said anything I wanted to, so long as you give it a path. You would never run the command dir with a path. So that's how you know you're running a script. You don't have to put the file name extension. It'll run without the .ps1, but you know you're running a script because there's a path in front of it. If there's not a path, you're running a command that's loaded into the shell's memory. Now that doesn't mean the command is safe. It's certainly possible for a command that's loaded into memory to do something awful, del *-recurs, right? But that's how you can kind of visually tell the difference between running a script and running a command. Those are important differences. All of those things, the file name extensions, the having to provide a path, they all are designed to help you know when you're running a script, to make it a little bit harder for you to accidentally run a script. But now we need to talk about the concept of trust. Who do you trust? Let's forget about PowerShell for a second, and let's assume, just for the sake of argument, that you're a bartender. Now somebody walks into the bar and, well, you can't tell for sure, but they look like they might be a little bit young. So you're here you've got a potential customer who potentially wants to drink. What are you going to do? Well, typically you're going to ask for some form of ID. Now that might be a driver's license, it might be some government-issued photo identification, whatever it is. You're going to look at that, and you're going to look at their little picture on there and make sure it matches them, and you're going to look at their name, and you're going to look at their date of birth, and that's going to give you the information you need. Now this card that they've handed you represents their identity. More important, it represents someone else's attestation of their identity. Now what does that mean? Well, it means you've got some organization. That's my Greek drawing with the columns to represent the government. You've got some organization, typically the government, that has already examined this person, verified their information, and they wrote that information on that card. Now, this person is allowed to carry that card around, and the card represents a government statement of that person's identity, including their date of birth. They put their picture on it, so you can make sure it's that person's information. So at the end of the day, who do you trust here? You don't trust this person. You don't trust your potential customer. If you trusted them, you would just say, hey, are you old enough to drink? And they'd say, yeah, I'm old enough. And you'd totally hand them a beer. But you don't trust that person. You trust the government. You trust whoever issued this identification. Now, in the world of computers, we call this a certification authority, an authority who certifies your identity. And we call this a certificate. Now, in the physical world, these certificates often have a number of features that let you verify their authenticity. They'll have holograms or microprinting or other features that are difficult to forge. In the computer world, certificates use cryptography. That way you know for a fact that the certificate was issued by a CA, and you know who that CA is. So how does this add up in Windows? Well, let's go look at the control panel. Now, the location of this differs a little depending on what version of Windows you're running, but you essentially want to make your way to Internet Options, Content, Publishers, Trusted Root Certification Authorities. This is a list of the entities that you trust to verify other people's identity and then hand those people an ID card. So, taking this back to the little metaphor we're doing right there, this is your government agency, which is a CA. They issue a certificate which gets carried around by a person or by a script file. So that's my little file icon. So that certificate represents their identity. Now, what this means is when I get a script that carries a digital signature, I can look at the digital signature and I can determine who signed it. So here's the trick. The certificates used for code signing or script signing are called Class 3 certificates, and that's why you'll see the word Class 3 down here sometimes. These are CAs who issue Class 3 certificates. Class 3 certificates are not issued to individuals. They're typically only issued to organizations. And before I, as a CA, hand you a certificate that says, yep, you are Microsoft Corporation, I'm going to make sure that's actually true. I'm going to check the company's public records, perhaps with their local Department of State. I'm going to check their Dun & Bradstreet corporate credit account to make sure I'm going to check some background information and make sure that before I give you an ID card that says, this is Microsoft, that you really are. So how do you sign a script? Well, we'll have to go back to PowerShell for that. There's a command called set authenticode signature. You give it the path of your script. You give it a path to your certificate as it's installed in your computer, and it will go open that script file, create a signature, and append that signature to the end of the file. Let me show you what that looks like. because Microsoft actually does this with the scripts that they ship with PowerShell. We'll just pop one up in Notepad. All the way at the bottom, bam. That is a signature. You can tell because it says begin signature block. Here's what that contains. It contains a copy of your identification. If I were to interpret that signature, run it through a checker routine, the checker routine would tell me this script was signed by Microsoft Corporation. It would tell me the certification authority that issued that certificate. I would have to decide if I trusted them or not. By default, if they're listed in that Internet Options control panel, you trust them. The signature block also contains an encrypted copy of the entire script, and I can compare that to the clear text copy up here. If the two match, then I know this script has not been modified since Microsoft signed it. If the two don't match, then you say the signature is broken. The script has been modified since Microsoft signed it, and I should not execute it because those changes might be malicious. Microsoft is no longer going to stand behind this script because it's been changed. So the signature block tells me who signed it, who issued that identity information, and it tells me that the script is intact, that it's not been modified. Now, does that mean the script is not malicious? Well, no, of course not. I could sign a malicious script and hand it to you, but you could use the signature block to find out my identity and track me down and hit me with a baseball bat in the side of the head, which is what I would deserve for having given you a malicious script. The trick here is really in the process. Let's go back to that control panel for a second, because this is where I think we tend to lose the concept here a little. This list says, I trust these people to do a good job of verifying someone's identity before they hand them a certificate. If you don't know what process one of these guys uses, they should not be on this list. Here's why. Let's say you get a malicious script, and let's say it's signed. You do the right thing. You pull apart the signature. You want to know how to do that? I'll show you how to do that. Get Authenticode signature. It's a big file, so this is going to take a second. There we go. So that gives me a copy of the signer certificate, which is kind of in a little hashed form. You could break that out if you needed to. It tells me that the signature is valid, meaning it's been signed, hasn't been modified since it was signed, and the certificate was issued by someone I trust. But that's where it gets back to process. If you go and you check the identity of the person who signed that script, and it was issued by a trusted CA who had a poor process, they might have issued a certificate for Microsoft, for example, to someone who wasn't Microsoft. Meaning you're looking at this malicious script going, man, this was signed by so-and-so. I'm going to track him down. And you get there and they're like, dude, I didn't do it. This is totally fake. I never signed this. I don't even have that certificate. And the problem is that you trusted someone who wasn't trustworthy. So the idea behind trust is only useful if you're going to manage this list. If you're going to worry about the process these folks use, decide if you think their process is a valid way of verifying someone's identity, and then only keeping the ones that you feel that way about. If you're just going to let anyone into that list, then signatures are pointless. If you don't know what the process is of verifying someone's identity, then you can't ever trust that identity, and so there's no point in looking for it in a signature. All right, so that's my little rant about certificates and signatures. Whoops. What's this mean for PowerShell? Well, it's this thing called the execution policy. Now, in PowerShell version 1, we had 4 execution policies, these ones, and then we picked up another one called bypass in PowerShell version 2 and later. So that's going to be everything, really. We'll stick in PowerShell version 2 here. This is kept by default in the local machine portion of the registry, which means by default only local administrators can run this command. This can also be set through a group policy object. Now, if you set it through group policy, that will override any local setting. In fact, if you try to run set execution policy locally, it'll say, hey, I changed the local policy, but it's not going to matter because there's a group policy that's overriding me. So, I mean, at least you know. So what does this mean? The default on all client operating systems and the default on server operating systems before Windows Server 2012 R2 is restricted. Restricted means you can't run scripts. You can only use the shell interactively. Now, on Windows Server 2012 R2 and later server operating systems, the default is remote signed. Remote signed means any script that's sitting on my local hard drive will run even if it does not have a signature. Any script that comes remotely must carry a signature. So remotely would mean maybe you pulled it over via HTTP or downloaded it as an Outlook email attachment. All signed means scripts will only run if they carry a signature. Unrestricted means scripts will run if they have a signature or not, although generally what you're going to see is a remote unsigned script will still create a security warning, even with unrestricted. Bypass turns that off completely. Bypass is actually not meant to be used as a standard execution policy. It's designed to be used when a developer is hosting PowerShell inside of another application, and their application is providing a security layer, and they don't want PowerShell providing another security layer, so they select bypass. Now look, I want to make sure you understand something here. Let's open up command.exe. Let's run PowerShell with -? to see its command line parameters. Any user can run PowerShell.exe -execution policy and specify a different execution policy for that session. So even if you're using a group policy to lock down your entire environment, a knowledgeable user can override that by running PowerShell.exe -execution policy. So let's start this from scratch. Here's a default shell. I didn't specify anything. I'm just opening it up with the defaults. Here's my execution policy, unrestricted, which you saw me just set. PowerShell execution policy, remote signed. Get execution policy, remote signed. Doesn't matter. I can always override the execution policy just by opening up my own copy of PowerShell and manually specifying that parameter. But that is not the activity of an uninformed person doing something unintentional. Remember what PowerShell is designed to slow down, not even stop. If you know how to run PowerShell that way, you're doing it intentionally, and you're doing it with some information in your brain. So PowerShell is just designed to stop uninformed people from accidentally doing something stupid, slow them down. It's not. So this execution policy it's not a security feature. It's a security helper. It's, you know what it is? It's like being in a missile silo, and you've got the big red button that ends the world, but there's a little plastic cover over the big red button so that you don't actually sit on it, you know, as you're walking around, or put your coffee on top of it and kill the world. But there's nothing stopping you, an informed person, from intentionally lifting that little plastic cover and pushing the button. Same thing in PowerShell. The execution policy is just a little plastic cover over the big red button. Anybody can lift the plastic cover if they know how. It's not designed to stop them. It's just designed to provide a little bit of protection from accidentally setting your coffee on top of the button and killing the world. So here in my lab, I typically use unrestricted, frankly. I don't sign my scripts. I do have customers that do. I have some folks that they don't use the execution policy so much as a security mechanism. They use it as a change management mechanism, believe it or not. They will get certificates from their own internal PKI in many cases, and they'll only give those certificates to administrators who are allowed to deploy scripts into production. They'll use the all-signed execution policy. Now that means any other administrator who writes a script has got to pass it up to those authorized people so that they can approve it, sign the script, and put it into production. That's a nice step, not really a security step. That's more of a change management process, and that's fine if that's how you want to use it. So there you go. PowerShell does require you to provide a path when you run scripts, and that's intended to help you visually differentiate between scripts and commands. It does not have a lot of dangerous default file name extension associations, which means double-clicking a PS1 file won't run it by default. And then there's that execution policy, which is designed to help slow down an uninformed person from unintentionally running an untrusted script, but it is not intended to stop malware. Malware is intentional. Malware is on your machine. You're already owned. So PowerShell is not a security barrier. There's just some things in here to try and keep an uninformed person from accidentally damaging themselves. Everything else, if you're intentional, if you're doing something on purpose, PowerShell is not even going to try to stop you. Hopefully you see where all that plays together now. I hope this has been informative for you, and I'd like to thank you for viewing.